Okay, guys, in this video, we are going to take a look at the solution for parallel circuit do right now, number one. Never gets old. Even like this, it doesn't get old. All right, so let's take a look at this problem. We have a 10 ohm resistor, a 20 ohm resistor, and a 30 ohm resistor wired in parallel and connected to a 15 volt power source. So we have our three resistors at 10 ohms, 20 ohms, 30 ohms, and 15 volts for our voltage. And then we want to know what is the equivalent resistance of the circuit. So again, with the equivalent resistance, because it's a parallel circuit, the inverse of the equivalent resistance is equal to the sum of the inverses of the individual resistors. And if we want to put that in our calculator friendly way, we would write it like this, and then we just need to insert our resistances. So we have 10 ohms, 20 ohms, and 30 ohms. And once we do that, we should get an equivalent resistance of 5.45 ohms. For the second part, they want to know what is the current of the circuit. So because I am looking for the current for the entire circuit, I need to use the equivalent resistance, and using Ohm's law, V equals IR, I know that the current is going to be equal to the voltage divided by the equivalent resistance. So the voltage is 15 volts. My equivalent resistance is 5.45 ohms, and that will give me a current of 2.75 amps for the entire circuit. Part C is asking what is the current across each resistor. So again, using the same formula based off of Ohm's law, I know that the current is going to be equal to the voltage divided by the resistance. Just in this case, because we're looking for the current on each resistor, we want to use the resistance of the individual resistors. So for the 10 ohm resistor, I know that the current is going to equal 15 volts divided by 10 ohms. That is going to give me 1.5 amps. For the 20 ohm resistor, I know the current is going to be equal to 15 volts divided by 20 ohms. That's going to give me 0.75 amps. And for the 30 ohm resistor, I know the current is going to equal 15 volts divided by 30 ohms, and that is going to equal 0.500 amps. Sorry about that. Social isolation doesn't apply to telemarketers, I suppose. All right, one last thing I just wanted to show you on this problem is that we have the individual current going through each resistance. If I add those three up, 1.5 amps, 0.75 amps, and 0.5 amps, that is going to equal my current going through the entire circuit. So that's just a good way to double check your values when you do a problem like this. Just at the end, add those three up and make sure that they that equal the current going through the entire circuit.